So today we'll go to our chapter 4, chapter 3, lines in 3 dimensions. So what do we mean by a line in 3 dimensions? Suppose these two are equations of the plane, intersecting planes. Okay, then these two equations taken together give the line L in a space. So that means what, in a space the line is nothing but what, equation of two planes taken together. Okay, so it is called unsymmetrical form of the equations of the line. So these two equations are nothing but a line. These two equations are nothing but a line. Okay. So now you can write the line also in the form of like this: a1x plus b1y plus c1z plus d1 is equal to 0 is equal to a2x plus b2y plus c2z plus d2. Okay. So this is also a line. This is a line. So these are the equations of a line. These are the equations of a line. Okay, equations, not a equation. Equations of a line. So in general, so it has two equations. Okay, so that is what two planes together is nothing but the equations of a line. Two equations of plane together is nothing but the equations of a line. Equations. Okay, note that this. Now, so we'll do the symmetrical form of the equations of the line. From this here, if a line is there, so for line it has a direction ratios or direction cosines. So if you consider the two planes together, from that we will not get idea of the direction ratios of the line or the direction cosines of the line. But if the line is in symmetrical form, easily you can find one point on the line and the direction ratios or the direction cosines of the line. So direction ratios, once we get the direction ratio, easily we can find the direction cosines. Okay, so okay, that is the symmetrical form of equations of a line. Okay, so find equation of a line passing through P x1 y1 z1, passing through P x1 y1, and having DCS L M N. Okay, so solution. Let P x1 y1 z1 be the point on the line. So suppose this is your line. So I will say this is what Q. Okay, so Q x1 y1 z1 is the point of that. What we want? We want to obtain the equations of a line. So to obtain the equations of the line, so we have to take a general point on the line. So we will take the general point on the line x y z, be any point on the line, and we have to apply some geometrical condition on P to obtain the equations of the line. Okay, so let P x y z be any point on the line. Okay, so then DRS of the line are what? X minus x1, y minus y1, z minus z1. But DCS of the line are L, M, N. Okay, so you know that the DCS and direction ratios are the proportional to each other. Okay, so therefore we have x minus x1 upon L, y minus y1 upon M, z minus z1 upon N. Okay, so See, if you consider these first two and first and last one are first with second, first with third, so we get the linear equations in x y z. That means the first degree equation in x y z. So that represent the plane. Okay. So this is required equations of a line of a line of a line. It is called symmetrical form of equations of a line. Equations of a line. Okay. So now we'll write a note now. Note. Equations of a line are x minus x1 upon n, y minus y1 upon m, z minus z1 upon n. Equation of line whose TRS are A, B, C are, I can write LMNN as ABC now. I can say this is R now. This ratio is R. Then, okay. So x is equal to what then? AR plus x1. Y is equal to what? BR plus y1. And Z is what? CR plus z1. So that is what? P AR plus x1, BR plus y1, CR plus z1 is any point on the line well, I will call this as 1 on the line 1. Okay, so that means the coordinates of any point on the line are in this form. Okay, so that means what? This is the coordinates of any point on the line 1. These are the coordinates of any point on the line 1. Okay, so now we'll solve some problem on it so that you will understand. So the denominators are nothing but the direction ratios. If the sum of the squares is 1, then they are the direction cosines. Okay. Find. We'll take a problem. Find the equations. Find the equations of the line passing through 2 minus 3 5 and whose DRS are 1 minus 2 2. Okay, so it is a one line problem, so we'll erase the find. Okay, solution. Directly write down the equations of the line passing through this and whose DRS are this are okay, x minus x1 is 2 upon 1, y plus 3 upon minus 2, z minus 5 upon 2. Okay, very simple. Okay, x minus x1, y minus y1, z1, and these are the direction ratios at the denominator. Okay, so the problem is over now. This is one line answer. Okay, find k. Next we will take the problem. Find k so that the lines x minus 1 upon minus 3, y minus 2 upon twice k, z minus 3 upon 2, x minus 1 upon minus 3, y minus 2 upon twice k, z minus 3 upon 2, and x minus 1 upon 3k, y minus 5 upon 1, z minus 2 upon minus 5 may be perpendicular. perpendicular to each other, Okay, solution. Given that the lines are perpendicular to each other. Okay, like I'll call this as 1, I'll call this as 2, perpendicular to each other. Okay, so DRS of line 1 R minus 3 twice K 2. Okay, so DRS of line 2 R 3K 1 minus 5. So we have the lines are perpendicular. Okay, so that is we have minus 3K, okay, plus twice K into 1 plus 2 into minus 5 is equal to 0. So the dot product is 0. A1 A2 plus B1 B2 plus C1 C2 is 0. So this is what 9K plus twice K minus 10 is equal to 0. So 11K is equal to 10. So K is equal to 10 by 11. Oh, here the minus है, so this is minus. Okay, so this is what then minus 7K, so this is what minus 10 by 7 now. Okay, so here it is minus 3, so here should be the minus 3. Okay, minus 3K twice K into 1 2 into minus 2. Okay, so this is minus 7 by K is the value. Okay, we'll take the next problem. Find the coordinates of the point of intersection of the line x plus 1 upon 1, y plus 3 upon 3, z minus 2 upon minus 3 with the plane 3x plus 4y plus 5z is equal to 5. Also find the distance from the point 3 minus 4 5 to the point where the line meets the plane or cuts the plane. Okay, solution. Given that the equations of a line are x plus 1 upon 1, y plus 3 upon 3, z minus 2 upon minus 2 is equal to r set. We'll call this as 1. The equation of plane is 3x plus 4y plus 5z is equal to 5. We call this as 2. Okay. Any point on the line 1 is of the form just we write this. Okay, what is that? So this is r 1, you have to shift there. So this is what r minus 1. Value of y now. Put y plus 3 is equal to y plus 3 upon 3 is equal to this. So 3r and then minus this. So 3r minus 3. So this is what then minus 2r plus 2. Minus 2r plus 2. Okay, so what we have to do? Find the coordinates of the point of intersection of the this. Okay, so this is the general point on the line, any point on the line. So what you want, a common point, common point. So we want to find the point of intersection means what? A point which lie on the line and lie on the plane. So this is the general point. So when this point lie, if it satisfies the equation of the line. Okay, so this point lies on the plane 2. So therefore we have where to put this point in the plane, right? So that we get a r, we get a particular value of r, and we get a particular point. Okay, so we have, so 3 into r minus 1 plus 4, 3r minus 3 plus 5 minus twice r plus 2 is equal to 5. Okay, so that is what is 3r minus 3 plus 12r minus 12 minus 10r plus 10 is equal to 5. So how many r are there? So this is 15r and minus 10, so 5r is there. Okay, so this is equal to how many constants? So this is minus 15, so minus 5, so this is 10 now. This is 10. So r is equal to 2. So r is equal to 2 now. Okay, r is equal to 2. So therefore the point of intersection of line and plane is, I will say this is m. Suppose this is m now. I have to put r is equal to 2 now here. So 2 minus 1 is 1. 2 minus 1 is 1. Then this is what? 6. 6 minus 3 is 3. Then this is what? Minus 4. Minus 4 plus 2 is minus 2. Okay. So we get a point of intersection of the line and also find the distance from the point is. Okay. So let P 3 minus 4 5 be the given point. And what you want? You want to find the distance from this. Okay. So therefore PM is equal to okay. We got a point of intersection of this. Okay. So PM is equal to root of, get after distance formula. So 3 minus 1 square minus 4 minus 3 square 5 plus 2 square. I have subtracted P from M. You can subtract M from P. Doesn't matter this. Okay. So this is equal to 2 square. This is the 4 plus 49 plus 49. So 49. This is what? Just shift 1 1 to this 50 50. So 102 now. This is what? 102. This is 102. Okay. Next, find the equations of the line passing through 2 minus 3 5 and parallel to the line x minus twice y is equal to 2z. Okay, so only this is your okay solution. Okay, so given that equations of a line are x is equal to minus twice is equal to 2z. Okay, I can write this of the form x is equal to this y upon minus half z upon 1 half. Okay, I can write in this form. I will call this as 1. Okay, so DRS of line 1 r 1 minus half 1 r 2. Okay, the required line is parallel to the line 1. So DRS of required line R 1 minus 1 half. Okay. So now what you want? Therefore the equations of a line passing through 2 minus 3 and having DRS 1 minus half R. Okay, so we are ready to find the equations of a line because we have one point on the line and we got the direction ratios of the line. Okay, so that is what is x minus 2 upon 1, y plus 3 upon minus half, z minus 5 upon half. Okay, you may keep this as it is, doesn't matter this. Okay, you may keep this as it is. Okay, if you this is no problem for simplifying this. Okay, next problem. Find the distance of the point 1 minus 2 3 from the plane x minus y plus z is equal to 5, measured parallel to the line x upon 2 y upon 3 is equal to z upon minus 6. Okay, so what is that? Suppose this is a plane you have given. This is a plane. This point P is here. Okay, so what is this? This point is 1, 2, 3. And what is this? This is what? From the plane this measure parallel to the line this. Okay, so that means what here? This is line. Okay, so this is a line. Okay, this is the line. This is your point P is here. And you want to find the distance of P from this plane. Okay, such way. So what you have to find? So this is your point now. This line is this should be the line parallel. This line. That means what you have to find? The equation of this line there. And just find the point of intersection of this line and this. Okay, so you get this point and just find the distance between these 2 points. Okay, so that means what you have to find the equation of line passing through P and parallel to this line. Okay, so you got the equation of line there. So then you have to find the point of intersection of the line and the plane. You get this point and then you can find the distance between these P. Okay, so first we will find the distance of so first we will find the equation of line passing through that point. Okay, so DRS of the line solution. DRS of the line x upon 2 y upon 3 z upon minus 6 r 2 3 minus 6. Okay, the equations of a line passing through P1 minus 2 3 and parallel to the line I'll call this as I'll call this as 1. Okay, no problem. This parallel to the given line R. Okay, so x minus 1 upon 2, y plus 2 upon 3, z minus 3 upon minus 6 is equal to R sec. I call this as 2. This is your line. Okay, so what you have to find? You have to find the point of intersection of this and the plane now. Point of intersection of the plane, and then you have to find the distance to this. Okay. Okay. Any point on this line, each of the form, I will say this is m now, no problem for this. Okay, so just twice r plus 1, then what? 3r minus 2, then minus 6r plus 3, okay. M lies on the plane, you have to write the equation of plane, because in the solution we don't have the plane. Lies on the plane, x minus y plus z is equal to 5. So therefore we have what is your x? Twice r plus 1 minus what is your y? 3r minus 2. What is your z? Minus 6r plus 3 is equal to 5. Okay, so find total r now. This is twice r minus 3r. See, minus r, so minus 7r now. Okay, so this is 1, then this is plus 2, this is 3. 3 plus 3 is 6 now. So 6 is equal to 5. So this one minus 1. So r is equal to 1 by 7. So r is equal to 1 by 7. So we'll put r is equal to 1 by 7 here, and we'll find a value. So we'll find a point P now. So therefore m is what? 2 by 7, then 3 by 7, minus 2, minus 6 by 7 plus 2. So this is equivalent to, so 9 by 7, minus 14. So minus 14, so minus 7 by 7, so 14, so 8 by 7. Minus 6r plus 3. This is 3 now. Okay. This is 3. Minus 6r plus 3. So this is wrong now. 21 minus 6. So this is 15. This is 15 by 7. Okay. 15 by 7. Okay. Now you have to find PM now. So this is root of 9 by 7. Your P is this. Okay, bracket square, plus minus 7 by 7 plus 2 bracket square, plus 15 by 7 minus 3 bracket square, okay. So this is equal to what? The root of, this is what? 9 minus 7, 2 by 7. So this is 4 by 49, plus this is what? 14 minus 11, 14 minus 11 is 3. So 9 by 49. 9 by 49. So this is what 21. 21 minus 15 is minus 6. So minus 6. So 6 square is 36 by 49. So this is what root 1. So this is 1. Root 1. This is 1. Okay. So this your distance is 1 now. Find the equations of a line passing through P x1 y1 z1 and Q x2 y2 z2. Okay, solution. DRS of PQ, DRS of PQR, what? x2 minus x1, y2 minus y1, z2 minus z1. Okay. So now we'll use one point on the line, that is x1, y1, z1, and these are our DRS. Okay. So therefore equations of PQ are x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay. So this is the required equations of line. Okay. So this is called 2-point form. This is called 2-point form of the equations of a line. Okay. Now we'll take a problem on it. Take a problem on it. Find the point. Find the point where the line joining 2 minus 3 1 and 3 minus 4 minus 5 cuts the plane twice x plus y plus z is equal to 7. So that means what here? You have to find the point of intersection of the line joining this point and the plane. This you want. Okay. Solution. The equations of a line joining the points 2 minus 3 1 and 3 minus 4 minus 5 are, I use one point, that is what? X minus 2, y plus 3, z minus 1. Then this I have to write this minus 2 plus 3 as it is, minus 1 as it is. Okay. I have to use the second point now. Just I have to write this 3 minus 4 minus 5. Okay. So we got this. So we will simplify this. X minus 2 upon 1, y plus 3 upon minus 1, z minus 1 upon minus 6. Okay. So I call this as 1. This is the equations of a line. Okay. Any point on the line, what you have to find? The point of intersection of the line and the plane. This you want only. You don't want the distance and all those things. Okay. You want only the point of intersection. Any point on the line 1 is of the form. I call this as M now. Okay. So is equal to R say. Is equal to R say. Okay. So what is there then? R plus 2. Minus R minus 3. Minus R minus 3. Minus 6R plus 1. Okay. This point lies on the plane. Okay. What is the equation of the plane? Twice x plus y plus z is equal to 7. Therefore we have, okay, we'll put m in the plane so that we'll get the value of r and we'll get a particular point. Okay, so we have, so twice r plus 2 plus minus r minus 3 plus minus 6r plus 1 is equal to 7. Okay, so how many r are there? Twice r, and this is what, minus 7r. So this is minus 5r then, minus 5r. Just connect the constant. This is plus 4 minus 3, so 1 is there. So plus 2, so this will what, 5. So r is equal to minus 1. So the value of r will be what, minus 1. Okay. So therefore m value r is minus 1. Okay, so minus r plus 2 is 1, then minus 2, because minus become plus now. So 1 minus 3 is minus 2. So this is 6 plus 1 is a 7. It's the point where the line cuts the plane. No need to write all the equations. Okay, where the line cuts to the plane. This is the required point. Okay, I hope that you understand this one. How to find the equations of line passing through 2 points, that is the 2-point form, and how to find the intersection of line and any curve. Now see, this is what, this is here, it is a plane. Actually what, this may be sphere or mini or anything now here. Okay, for any curve you can find a point of intersection of line and any curve or any surface also you can find. Okay, so I hope that you understand this one. We'll discuss the problem. We'll discuss the problem. Find 1. Okay, find k so that x minus 2 upon 3k is equal to y plus 3 is equal to z plus 4 upon 1 may be parallel to the plane twice x plus 3y minus 4z plus 7 is equal to 0. Just we will discuss this to find where the line x minus 1 upon 2, y minus 2 upon minus 3, z plus 3 upon 4 meets the plane twice x plus 4y minus z plus 1 is equal to 0. And third one, find the distance of the point minus 1 minus 5 minus 10 from the point of intersection of the line x minus 2 upon 2, y plus 1 upon 4, z minus 2 upon 12, and the plane x minus y plus z is equal to 5. And the last one, course, find the distance of the point 3 minus 4 5 from the plane twice x plus 5y 5x plus 5y minus 6z is equal to 16. Measure along a line with the line with DCS proportional to 2 1 minus 2. Okay, so these are the four problems. See, find the value of k so that this line may be parallel to the plane. Okay, so now see, suppose this is the plane and this line is parallel to the plane. But what are these coefficients of x, y, z from the plane? This represents the DRS of the normal to the plane. So this is the okay. So what are the DRS of this is normal to the plane? Okay, what is the DRS of the normal to the plane? 2, 3 minus 4 are the DRS of the normal to the plane. And line is parallel to the plane means this line is perpendicular to the plane. So that means what here? This is 3k into 2, 2 into 3, 4 into 1 into minus 4. This product is 0. DRS of the line are what? 3k to 1. DRS of the given line are. Okay. DRS of the normal to the plane are 2, 3 minus 4. So normal to the plane is this line is the line 1 is parallel to this. That means the line is perpendicular to the normal to the plane. Okay. So therefore this 3k into 2. Okay. So directly you can write the line is parallel to this plane. Therefore 3k into 2 plus 2 into 3 plus 1 into minus 4 is equal to 0. You can find the value of k. No problem for this one. So this is what you have to find, just point of intersection. Call this as r. Okay, so general point you can find here and just put the point here. You get the value of r now and then replace the value of r. You will get the point of this. Okay, find the distance of the point P from the points of intersection of this. So first you have to find the point of intersection of this one. You have to find the point of intersection of this one. That will equal to m. This is your P now. Just you can find Pm now. Okay, find the distance of the point this from the plane. Okay, so your P is here now and your plane is here. Okay, so what here? Measure along the line with the direction ratio. So this is the line whose direction ratios are this. Okay, so that means you have to find the equation of line passing through this and having DRS this. Okay, and then find a point of intersection and then find a distance. Okay, we did this problem here. Okay, we did this problem. Okay, the line is parallel to this plane. That means what you write? You have to write the equation of a plane, the equations of a line passing through the point and having direction ratio 2 1 minus 2. You get the equation of line. You have to find the general point and that point will be on this plane. You have to just find that point. You get m and this is your P now. So just find Pm. Okay, so I hope that you understand this one. Okay, so we stop here.